Okay, in this tutorial we will review one problem from each of the sections of the fall semester review, so you have a good understanding of how each type of problem is supposed to be solved, simplified, graphed, whatever the case may be. So let's jump into it. Let's pull up our homework assignment real quick here. All right, we're looking at the fall semester review, and we're given the first question, which, if we look carefully at the language, asks us to simplify each expression. Okay, notice it doesn't say solve, it says simplify. And if we look at numbers 1 through 4, there are no equals signs. So we're just going to simplify the expression. Okay, so first thing to do is to write it out. So you're still looking at my screen, but I'm writing it out. Number 1 is -6. Okay, multiplied by this parenthetical expression. Okay, so everything inside the parentheses will need to be multiplied by -6, and what's inside the parentheses is -2 minus 7b, close parentheses, minus, open parentheses, b minus 6. Now, just a point of vocabulary, the terms inside the parentheses, because there are two terms, okay, here's a -2 and here's -7b. This is called the binomial because there are two terms. There's -7b and -2. Over here's another binomial, bi meaning 2. So b minus 6, you have two terms. You have b and what could be -6, okay? So those are binomials. So when I say anything with the binomial, I'm referring to a group of two. All right, just a point of vocabulary. Okay, let's go back to our workspace. And here's the problem. So we're going to simplify this. Now to simplify, what I need to do is focus on my order of operations, the first of which is parentheses. So I have to deal with these two parentheses here. And the way I'll deal with them is by distributing the term to the left of each parenthetical expression. This thing is a parenthetical expression, and the thing that's inside the parentheses is a binomial. Okay, so I'll multiply -6 by -2, and I'll multiply -6 by -7b. Then over here, I'll distribute this negative sign, which is really a -1 multiplied by this parenthetical expression. Okay, so again, this is a binomial inside parentheses multiplied by -1. And what that means is -1 needs to be multiplied by each term or distributed to each term inside the parentheses using multiplication. All right, so let's get to work. -6 times -2 is +12. -6 times -7b is +42b. Okay, so you multiply this -6 by this -7 right here. And what that -7 is called, another point of vocabulary, this is a coefficient. So this -7 is a coefficient of this letter, which is called a variable. So that's b. So I'm multiplying -6 times the coefficient, -7, and the variable that goes with the coefficient just comes along for the ride. So I have -6 times -7b, which gives me +42b. Right? Now we'll move on to this parenthetical expression. So in this case, we're going to multiply -1 times b. Well, again, there is a little 1 hiding in front of the b, so I have -1 times 1b, and that gives me -b. So just write that down. Looks like you wrote -b. And then again, -1 times -6. Okay, so negative 1 times negative 6 is just positive 6. Okay, so we have positive 6 there. Now, I'll play a game called Combine Like Terms. I'll use blue ink to circle the numbers that are by themselves, and these numbers are called constants. And just to be super careful, I'll also circle the sign that goes with the number. Okay. Now 12 doesn't have a sign next to it because it's the first term in the expression. And it's just known that unless it has a negative sign, then we can understand 12 to be a positive number. Okay. The other type of term that I have in this expression are these coefficients and variables. So here's plus 42b or positive 42b. Circle that. And I also have negative b. So I'll use red ink to indicate that I'll be combining the b terms, so to speak. All right. So now I add the different groups of terms that I have. So 12 and 6 go together. Okay, so I have 12 and then positive 6 or plus 6. Okay, I'll put those in parentheses just so I know to handle them together. And then I have this other group of b terms. Okay, so here's my b terms. I have 42b, positive 42b. Okay, positive 42b. And I also have negative b, so minus b. You put those in parentheses. All right, and so now it's time to work out our different types of terms. So here I have 12 plus 6, which is just 18. And here I have 42b minus b. So again, if there's a 1 in front of this b right here, I have 42b minus 1b. So you have 42 minus 1. So you have 41b. It's still positive, so I write plus 41b. Okay, so that is our final simplification. Put a little box around it. And then check your answers to see if that's one of the answer choices. Okay, we'll transition back to the assignment, and we see that C is in fact the answer choice that corresponds with what we found, 18 plus 41b. Okay, so number 1 is C. Okay, now we'll move on to number 2. Or rather, that's the only question we'll solve from the first section. So we're going to solve the second question we're going to solve is actually going to be from the next section of the homework, because I just want to show one problem per section. We'll go down to the second section of the homework. This section says solve each equation. Okay, and this a different verb. In the first section we were told to simplify, now we're told to solve. And the reason we're told to solve is because there's an equals sign, and that wasn't there in the first set when we were told to simplify. There's no equal signs anywhere in 1 through 4, but starting at number 5, 5 through 10, there are equal signs. Okay, so we'll solve number 5, and I'll write it. You can pause the video at any time so you can catch up with my writing if I'm writing too fast. You can also toggle the speed settings on YouTube and double the speed of my delivery here if this is going too slow for you. But this is going to be number 5. And what we're given is 8, open parentheses, 4 minus x, close parentheses, equals, that's what makes it an equation and not an expression, equals negative 10, open parentheses, x minus 5, close parentheses. Okay, so now to solve this equation, we'll go back to our work surface. And we've written out the equation. Once again, we're going to distribute the term that's next to the parenthetical expression. So here, I'm just going to ignore the right side for a moment, and I'll just think, I need to get this 8 associated with each term inside the parentheses. So I'll distribute the 8 like that using multiplication. On the right side of the equal sign, I have a negative 10 that I need to distribute through each term of this expression inside the parentheses. And once again, just a term of vocabulary, these are binomials because there are two different terms. If they're unlike. This is an x variable, and this is a constant of negative 5. Here is a constant of 4 and a variable of negative 1x. Okay, so these are binomials. Just want to hit that vocabulary a little bit so you understand the terminology that you see in the book. So now I'm going to distribute negative 10 through the parenthetical expression like that. So here we'll write out what we're doing and we'll start solving this out. 8 times 4 is 32. And now I'm going to multiply 8 times negative x. And remember, hiding in front of the x is a 1. So it's really 8 times negative 1x. Well, 8 times negative 1x is negative 8x. Negative 8x. Okay, equals. Now we'll go over to the right side of the equal sign. Negative 10 times x. Well, that's negative 10 times 1x. So that's negative 10x. Negative 10 times x is negative 10x. Now we're multiplying negative 10 and negative 5. Well, negative 10 times negative 5 is positive 50. So we're just writing down what we get from each of our little intermediate calculations and the associated sign. So it starts to look like another equation. Now we've gotten rid of our parentheses, which is good. So now we're going to combine like terms. And that's our goal, to combine like terms. Now, because we're using an equation to do this right here, in order to get the x variable by itself, because I kind of want this thing to say x equals something, okay? So in order for me to get x by itself, I need to gather all of the x terms together on the left side of the equal sign, and then make sure all my other terms are on the right side of the equal sign. So in order to do that, my focus is now on negative 10x. I want to move this over here. Now, how do I move it? Well, the way to get it over here is to add, because it's negative 10x, if I want to move it to this side of the equation, I have to do the opposite sign. So it's negative 10x, therefore I will add 10x to both sides. Make sure you're stacking it up just like this. It'll help you keep track of what you're doing. Okay, now if it helps you, draw a line like it's an addition problem. And negative 10x plus 10x, it's equals to 0. So this cancels out. That's what we wanted. Now, before we do this little addition here, let's not leave out the 32. The 32 just comes along for the ride. Okay, we haven't done anything with the 32 yet, so it's 32. Now we have to deal with this, negative 8x plus 10x. Well, again, you're going to add the coefficients, negative 8 and positive 10. And if you add negative 8 and positive 10, you come out with positive 2. And remember, they're coefficients with a variable, so it's positive 2x. So what we'll do is write plus 2x equals. Now the only thing left on the right side of the equal sign is this 50, so we'll write 50 right here. Okay. All right, so now my attention is shifting. Now my attention's on the 32 because my goal is to get x by itself. I can't do anything with that 2 yet because added to it is this 32. So first I need to subtract 32 from both sides. Just like that. Remember, the leading term is 32, so there's not a plus sign, but it's really positive 32. So I have positive 32 minus 32 gives me 0, so I cross that term out. Okay, the 2x comes along for the ride. So 2x equals, okay, now 50 minus 32. Now if you don't have a calculator, like I don't have a calculator, you can do subtraction manually and borrow from the tens column. And then this becomes a 10. 10 minus 2 is 8. And then 4 minus 3 is 1. So I have 2x equals 18. Okay. Now my attention is now focused right here. 2x. I want the x by itself. So I can the only thing I can do here is do the opposite of the thing that is currently being done. So let's take a look at this for just a second. Right now, 2 is multiplied by x. So if I want to get rid of it and put it on the other side, I have to do the opposite operation. And the opposite of multiplication is division. So I will divide both sides of my equation by 2. Just like that. On the left, 2 divided by 2 cancels out because 2 divided by 2 is 1. And we don't need to write the 1. So I just cancel them out. And that leaves x by itself, which is what I wanted, equals. Now 18 divided by 2 comes out to 9. So x equals 9 is my solution. We were asked to solve, so we come up with a solution. We solved this equation for x. X equals 9. Now we'll check our answer choices to see if we have in number 5, 9 as an answer choice, and we do here. A is 9. Okay, so going back to our work surface, we see that A is the correct answer. X equals 9, right? Okay, we'll create some more space now, and we'll work on the first problem from another section. So that was number 5. So far we've done number 1 and we've done number 5. If I show my screen again, go back to the problem set, scroll down a bit. We're going to work on this next section. It says here, find the slope of a line perpendicular to each given line. Recall perpendicular slopes are negative reciprocals of the original slopes. Okay, so here we're going to be working on number 11, 6x plus y equals negative 5. So this is number 11. And what we're given is 6x plus y equals negative 5. And what we're asked to do is find the slope of the perpendicular. Okay, so we'll get back to our work surface. Here's our number 11. Now this problem right here, this equation, this is currently in something called standard form. I mentioned that this was going to come up quite a bit. So standard form is ax plus by equals c. All right, so right now a is represented by 6, b is represented by that invisible 1 that's hiding in front of the y, and c is represented by negative 5. Okay, what we're going to do is unravel this equation and put it in this is called standard form. we want this in slope-intercept form. So this is standard form. Quick review. Standard form means that you're going to have the x and the y terms on one side, and any constants are just numbers by themselves. I think I said that wrong. You're going to have the x and the y terms on the left side of the equal sign with their coefficients, and then you're going to have any numbers that are by themselves on the right side of the equal sign. Now here are the other rules. For standard form, a, b, and c must be whole numbers, okay, or integers, and a should be positive. It's not required, but most of the answer choices will follow the strict form, so a will be positive, and that'll become important later. Right now, we want to transform from standard form into slope-intercept form. So this is our first step, slope-intercept form. Okay, slope-intercept form is y equals mx plus b, where m is the slope. Okay, we've got the variable x, and then plus b, which stands for the y-intercept, right? This is the one most people are familiar with. So what we have to do is reorganize, okay, our terms in order to get y by itself equal to some number x plus some number. So let's just start working on it. It should be clear when we work the problem. My attention is immediately right here on 6x. So I'm focused on 6x because I want to move that term over here. So I have mx. That's what I want. So right now it's positive 6x, so I have to subtract 6x from both sides. Just like that. Now on the left side, 6x minus 6x just cancels, okay, leaving y by itself. So I have y equals, now let's look about the right side of the equation. This is where a lot of people get confused and mistakes are made. There is a temptation to do something with the negative 6 and the negative 5. But remember, these are two unlike terms. So we should actually maybe circle negative 5 with red and circle negative 6 with blue. You cannot combine these terms. So you just have to write them out next to one another. And by convention, if I'm trying to get this into slope-intercept form, I should write the term that has the x first. So I'll write negative 6x, and then I'll write the term that is just by itself as a number next to the right of the negative 6x. So minus 5. So now what I've done is I have converted my original equation from standard form to slope-intercept form. Now we're ready to start analyzing this equation. Okay, remember y equals mx plus b. So I have to find out what is the slope of this equation right here. What's the slope of this equation for a line? Well, it's in y equals mx plus b form. So y is y, okay? You just write it out like this. Y is y, m equals, now pay attention here, m is equal to negative 6. It's the thing that's sitting in front of the x. So m is negative 6, and it says y equals mx plus b. Well, in this case, we're adding a negative number. So b, or the y-intercept, is negative 5. Right? Now, at this point, it's helpful because remember what we're trying to do. We're trying to find the slope of a line that's perpendicular to this line. So it might be helpful to actually graph this line and kind of see what we're doing. All right, so we'll graph it. Okay, so let me draw the graph real quick. Right, and then just looking at my terms here, so I've got enough space. -1, -2, -3, -4, -5, 6. Okay. So here's my y-axis, here's the origin point, and here's my x-axis. Now I'll label -1, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. And over here we have 1, 2, 3, 4, 5, 6, just like that. If I'm graphing this equation, I start at the y-intercept of -5. So I go down the y-axis to -5, and I put a little dot, and this is the y-intercept, which is 0, -5. Okay, and then what do? Well, I use the slope to tell me rise over run, all right? So the slope is -6, all right? So if the slope is -6, I have to consider rise over run. So m equals rise over run. And m is equal to, in this problem, -6, and you could say over 1, because it's a whole number. Right? So what does it mean? It means that we either have to go down 6 and then over 1, or up 6 and over to the left 1. So I can either, if I'm going to use rise over run literally, I have to kind of do it in reverse. I can go up 6 and 1 to the left, or if I want to follow this literally, I can go down or fall 6 over 1 to the right. This skill of graphing is so important that I feel like you should take every opportunity to do it. So, I'll show both ways. If I was going to go up 6 and over to the left 1, I would say start at the y-intercept, the known point, and go up 6. Up 1, 2, 3, up 4, up 5, up 6, and then over to the left 1. Okay, so here's a point. If I was going to use the other method, the kind of fall and then to the right, I'll go down 6, starting at the y-intercept. Down 1, down 2, down 3, down 4, down 5, down 6, over 1. Okay, I'm kind of running off the page. The important thing here, there's that little dot down there. The important thing here is that when I put a straight edge up to it, all those points I just plotted should align, and they do. So here's the equation of the line graphed. It's this downward sloping line. Okay, so this equation that we just graphed is y equals -6x minus 5. Okay, so if I wanted to find the equation of a line that was perpendicular to this line, what I would be trying to find is the equation of a line that kind of looks like this. Something like this. Okay. And these two lines, because they're perpendicular, form a right angle to one another. All right? So we're trying to find the equation of this red line right here. We can kind of estimate what we think it will be visually, if you wanted to. We'll do rise over run. It's going to be a positive slope because it's tilting up. So if I'm looking at this, I start at this point, I can go up 1 over 1, 2, 3, 4, 5. And that appears to be a point. So I went up and I went over 5. Now that's not right. So I think I drew it wrong. Up 1 over 5. 1, 2, 3, 4, 5. I think I drew it wrong. So if I had drawn this a little bit more precisely, maybe I wouldn't have made that mistake. Let's see here. This is why it's be careful to draw your lines precisely. Here, I'm going to kind of fudge this a little bit. This is the line we want to draw. It just proves that you can't rely on the visual data sometimes. So what we really want is we want the point to cross right there. So this would be up 1 over 2 over 3, 4, 5, and 6. So it looks like it has a slope of positive 1/6. Again, I realize I kind of messed it up by drawing it wrong, but this kind of proves why using algebra to find this is important. Okay, so enough with the graph. That's the equation we're trying to find. And here's how we'll find it. Because we're trying to find the equation, the slope of a perpendicular equation to the line, what we need to do is find the negative reciprocal slope. So here we'll talk a little bit about negative reciprocal. The way you write negative reciprocal is negative m raised to the negative 1. This is how you write negative reciprocal slope. Okay, so I'll give you an example over here to the left. If I have 2 and I want the negative reciprocal of 2, what does that equal? Well, first you take the reciprocal of the number. And remember, any whole number can be written as that whole number over 1. So I've got to take the negative reciprocal of 2. And the way that looks is, okay, I'm going to take the negative reciprocal of 2. Well, that looks very complicated, but any number raised to the negative 1 just means write that number underneath a 1. So that equals negative 1 over 2. So the negative reciprocal of 2 is negative 1/2. Now let's do another one. How about the negative reciprocal of negative 1/2? So that's the negative reciprocal of negative 1/2. What does that equal to? Well, take the negative reciprocal of negative 1/2. Looks complicated, but let me pay attention to a couple things here. I got a negative times a negative. So it's probably going to end up being a positive number, but first I have to deal with this. Well, I guess I have to deal with the parentheses first. So I have negative times a negative, so that's a positive. So I have now 1 over 2 raised to the negative 1. Right? So now we'll deal with the exponent. When I raise a number to the negative 1, it just means flip it. Okay, so just flip it. If this pen is that 1/2, I'm going to flip it like that. So 1/2 flipped over is just 2. So the negative reciprocal of negative 1/2 is positive 2. In other words, These two things are negative reciprocals of one another. They just can go back and forth like that. So that's a little mini tutorial on negative reciprocal, and that will give you the slope of a line that is at a perfect 90 degree angle to the slope that you already have. So in our case, for our problem, remember m equals 6. So now I need to find the negative reciprocal of our existing slope. So that's equal to the negative reciprocal of negative 6. Just like that. Again, it looks complicated, but take it one piece at a time, it'll be okay. First, deal with the negative sign here. You have a negative times a negative, so it's like negative 1 times negative 6, and that gives you positive 6. So I have 6 raised to the negative 1, and that tells me take the reciprocal of that number. So the negative reciprocal of negative 6 is positive 1/6. That is negative m, negative 1, positive 1/6. All right, so that would be our answer for this problem, number 11. Let's go to our answer choices and see if that is in fact one of our answer choices. Positive 1/6. So for number 11, it looks like it's A, positive 1/6. Right? So this would be A. And just, even though I did mess it up, corresponding over here, that means that the slope of this line is 1/6. So you rise 1 and you go over 6 places. 1, 2, 3, 4, 5, 6. And you should still be on that line. Again, I kind of messed it up because I was trying to guesstimate the angle with this straight edge. It was a bad idea, and I regret it. But that's why we solve the problem algebraically, because visual interpretations can be off, not to scale, wrong, confusing. So solve it numerically, algebraically, you'll get it right every time. So that's number 11. Okay, and let's see what's coming up next. We'll transition back to the problem set. So before we were doing perpendicular, now we're doing parallel. It says find the slope of a line parallel to each line. So now we're on number 15. Okay, so I have number 15. And what we're given here is negative 9x minus 2y equals negative 10. Flash back to our work surface, and here's our problem. Okay, so we want to find the slope of a line that's parallel to this line. Now here's the deal. Parallel lines have the same slope. I can prove it to you. So if I have two lines and they are parallel, they have the same slope. Just like, so that's the same slope. M of line 1, the slope of line 1 is equal to the slope of line 2. So here's line 1 and line 2. Perpendicular is just the opposite, right? So if I have line 1 here, and I find the line that's perpendicular to line 1, line 2, so this is line 2, and this is line 1, then if I want to relate these two slopes, you have m, okay, and then what you do to transform m to the slope of, so this is slope of line 1, is not equal to the slope of line 2, but it is equal to what you do is you transform this by taking the negative reciprocal of the slope of line 1. So here we've got, so the slope of line 1, M1, you take the negative reciprocal of that, and that gives you the slope of line 2. Okay, so those are not equal to one another. So all we have to do with this problem on number 15 is just find the slope of this equation, and we'll already have the slope of any line that's parallel to it. Doesn't matter what the y-intercept is. So basically I just need to solve this for y. So let me write it again. Negative 9x minus 2y equals negative 10. All right, so we'll solve this now. This is in standard form, and we need to get it into slope-intercept form. Okay, so I'm focused in on negative 9x. I'll add negative 9x, or rather I'll add 9x. I'll do the opposite sign. I'll add 9x to both sides. On the left side of the equal sign, this cancels out, and I'm left with negative 2y by itself equals, and remember, oil and water here, apples and oranges. I have 9x and then negative 10 minus 10. Okay, so I haven't yet come to the end yet because I have to divide both sides now by negative 2. Divide both sides by negative 2. And I'll show you how to do this another way than I usually do. Rather than putting a huge line underneath the right side, what I can do is just divide each term by negative 2. Because that's what I'm really doing. Okay, so I'm dividing every term by negative 2, negative 2, negative 2, negative 2. Okay. So now the negative 2's on the left cancel, leaving y by itself. And I have y equals, now 9 over negative 2x is what we'll write. So the proper way to write this, instead of 9x divided by negative 2, is to write negative 9 halves, negative 9 over 2x. Okay, we've already got our slope. So, and then we have negative 10 divided by negative 2 gives you positive 5. In other words, we found the slope-intercept form equation of the line with a slope. Okay, remember, y equals mx plus b. The slope is negative 9 over 2, and the y-intercept b is 5, positive 5. So what I'm really going to find here is that m equals negative 9 over 2. Okay, and that's going to be the slope of every line that's parallel to this line. In fact, the fact that the slopes are the same is the chief reason that they are parallel to one another. Okay, so what I'm looking for is negative 9 over 2. Let's go back to our answer choices. And looks like A gives me negative 9 over 2. Okay, look, they're playing with you in B. And then they drop the negative sign in C, and they're playing with you and dropping the negative sign in D. So what we're looking for is A, negative 9 over 2. Okay, so number 15 is A. All right, so now time to move on to the next section. Okay, here it's asking us, write the standard form equation of the line. Recall perpendicular lines have negative reciprocal slopes. Okay, so we've already done part of this. So here's what it's giving us. Number 19 is giving us, we have a line that's passing through 2, 1 that's perpendicular to line with the equation y equals 2x minus 2. So we're passing through 2, 1. And you might want to get your graph paper out because we're going to graph. And then this is perpendicular to y equals 2x minus 2. All right? Okay, now the first thing I want to do is show this graph so you can see what you're looking at. Let's draw a graph. Again, graph drawing skills are critically important. I'm just labeling the graph kind of how we've been labeling it. Should always be careful about how you label your graphs and use graph paper whenever possible. All right, so let's graph this equation right here. So I'm going to focus in on the y-intercept, which is -2, and I go down the y-axis to 0, -2, and I'll plot that right here and label it 0, -2. And then what do I do next in order to graph this line? Well, I'm going to focus on the slope. So y equals mx plus b. M is 2. So if m is 2, then my rise is 2 and my run is 1. I'm going to go up 2 over 1 to the right. So starting from my y-intercept, I go up 2 over 1 to the right. Up 2 over 1 to the right. Up 2 over 1 to the right, just like that. Then you kind of connect the lines, draw it in. We'll try to be even more careful this time. Okay, and this is the equation in blue, y equals 2x minus 2. And what we're trying to find is an equation for a line that's perpendicular to this one that passes through a specific point. And that specific point is this right here, 2, 1. So we need to plot that point. 2, 1. 2 is the x value, 1 is the y value. Okay, it might even be helpful to label that x, y. So I'll go to 2 on the x-axis and then up 1. There's my point, okay? And that point is 2, 1. And what I'm trying to find is a line that is perpendicular to that line. I want to make sure that I actually get it right this time. Let's see if I have the tool that I need. I've got not exactly. I don't exactly have the tool I need. Also, we'll just try to visually do this again. Okay, what I'm looking for is a line that is perfectly perpendicular at a 90-degree angle to my existing line. And I want it passing through that point. So this is a super sketchy way of doing this, but I draw this in like this. So that is the line that I want to find the equation of. All right, so this is going to be y equals something. Well, we actually know a little bit about this line. Okay, what is the slope of this line? Okay, we know it's a negative slope, so let's evaluate it. Let's start at we know 2 points, all right? So we know the 2, 1 point, and it looks like this line passes through the y-axis at 0, 2. So I actually have 2 points. I have 0, 2, and 2, 1. I can actually estimate the slope visually. Starting at 0, 2, I go down 1 over 2. Okay, so look, down 1 over 2. So it appears that y equals negative 1 over 2. 1/2 x, and then remember, it's y equals mx plus b, so my y-intercept of my perpendicular line appears to be 2, so plus 2. I think that's the equation I'm looking for, but I'm going to figure it out algebraically. Okay, so first I'm going to declare that the slope of the first equation is 2. So it's kind of like this. You're setting this little thing up. If the slope of the first equation is 2, then the slope, the negative reciprocal slope, is equal to negative 1 over 2. All right, so we just kind of algebraically proved that our slope that we found visually was correct. Okay, so now we have to create the equation of the line algebraically. So we want that line to pass through point 2, 1. So when we have one point and a slope, this is the slope we're going to be using. Our slope, our negative reciprocal slope, our perpendicular slope is now equal to 1/2. So what we want to do is use the point slope formula to solve this. Now, point slope formula is y minus y1 equals, well, typically it's equal to m, but because we're trying to find the point slope formula for a perpendicular line, we'll say y minus y1 equals the negative reciprocal slope, m, negative m to the negative 1, x minus x1. We're just going to fill in the numbers now, substitute numbers for variables. So we have y minus y1. Now y1 is this number up here, 1. Y minus 1 equals negative 1/2. That's the negative reciprocal slope, open parentheses, x minus x1, 2. Okay, so x minus 2, close parentheses. You should pause the video and get yourself to where you can get to here, all right? If you can get to here, you're going to be pretty close to getting it right. So make sure you go through this until you understand how to set this up. Now it's all spelled out for you right here, so I would pause the video, go back to where I wrote down 19 and just follow the steps, including the graphing, quite frankly. All right, so now we have to solve this out and get it into slope-intercept form. So we're going to distribute through the parentheses negative 1/2 times x and negative 1/2 times negative 2. All right, so I have y minus 1 equals negative 1/2 times x, which just means negative 1/2 x. Now, negative 1/2 times negative 2, if you do that math over here in the corner, negative 1/2 and negative 2 over 1. Multiply the top, multiply the bottom. I got negative 1 times negative 2, which gives me 2. And I have 2 times 1, which gives me 2. So I have 2 over 2, which is just 1. So negative 1/2 times negative 2 gives me positive 1. Okay? So now my attention's focused back over here. I want y by itself, so I need to add out the 1 from the left and then add it to the right, just like that. They cancel on the left, leaving y by itself. So y equals negative 1/2 x. 1 plus 1 is 2, so plus 2. Now, it would be lovely if that was the answer, right? That is actually the equation of the line. Now, the cool thing is it matches. These two match. You know, if you freeze frame the video here, you have y equals negative 1/2 x plus 2. This is what we estimated visually, y equals negative 1/2 x plus 2. That's a good indicator that we're probably right, okay? So, here's the problem. If we go back to our answer choices, all of our answer choices are given in standard form, okay? What we found was an equation in slope-intercept form, but what we're given as answer choices are all in standard form. So what you could do is go through and find out the slope-intercept version of each of these equations, or, easier, just convert the equation you found into standard form, because you can do that. So now we're going to convert this equation into standard form. So we're going to convert y equals negative 1/2 x plus 2 to standard form. That's what we're going to do right here. So what we're given to start with is y equals negative 1/2 x plus 2. Remember, standard form is ax plus by equals c, where a, b, and c are whole numbers and a is positive. So we want the x and the y on the left side and everything else on the right. So let's do this. First thing, I'm going to zoom in on negative 1/2 x. I want to move that over here to the left. So I have to do the opposite sign. Add 1/2 x to both sides. Plus 1/2 x plus 1/2 x. All right. So here we have to kind of look at our form and think about how we're writing this. So these cancel. Over here I have 1/2 x. I want the x term up front. 1/2 x. And then y is positive, so plus y equals 2. All right? Okay, so the question is, are we done? No. We are not done because the leading term is a fraction. And I said everything had to be a whole number. All right, so what you're going to do is perform a little intervention surgery on this equation. And we're going to multiply the entire equation, or every term of the equation, by some number that will get rid of that fraction. And so the thing that will get rid of the fraction is the reciprocal of the fraction. Whatever the fraction is, 1 over 10 times 10 over 1 equals 1, because it's 10 over 10. A billion over a billion, okay, so 1 over a billion times a billion over 1 equals 1. So therefore 1 over 2 times 2 over 1 equals 1. So I'm going to multiply the whole equation by 2 over 1. We'll distribute that here, distribute it to the y and to the 2. All right, so if I write that out, I have 2 over 1 times 1 over 2, which is 2 over 2, which is just 1. So I'll write x. Then I have 2 over 1 times y. So remember there's a 1 hiding in front of the y. 2 over 1 times 1y. 2 over 1 times 1 is 2. So just plus 2y equals 2 over 1 times 2. So some people were getting this mistaken. I have 2 over 1 times 2 over 1, because any whole number can be written that way. So 2 over 1 times 2 over 1 is 4 over 1, which can be written as 4. So that's just 4. So that is actually the answer. That's the standard form equation of the perpendicular. So this is standard form perpendicular. So let's go see if we have an answer choice that says x plus 2y equals 4. X plus 2y equals 4. Look at that. B. So number 19 is B. X plus 2y equals 4. All right. That was fun. So now we'll get another page going here. Okay, so let's go look at our next section in our homework. The next section says, write the slope-intercept form of the equation of the line described. All right, hint, m equals slope, b equals y-intercept. Remember that parallel lines have the same slope. Okay, so this is going to be a little bit easier than the previous section because the answer choices are all given to us in slope-intercept form. All right, so kind of set this up again. I'll write down number 23. And number 23 says passing through points 3, negative 1, and then parallel to y equals negative 2x plus 2. Okay, so we'll go back to our equation. This is actually a bad example. I'm going to show you something here. So let's just think about this for a minute, and we can skip this section because this is a little bit too easy. What you're looking for is the slope of the line. Okay, so you're given y equals negative 2x plus 2. The m value here is negative 2. So look through your answer choices and see what you can eliminate. Well, here this is positive 2, so the slope of any line that's parallel to this line has the same slope. Okay, so you got to find a slope of negative 2. Here the slope is 5, that can't be right. Here the slope is 1, that can't be right. Positive 2, that can't be right. So just by process of elimination, you've gotten A. And I'm pretty sure that you can do that for each of these. Maybe not. So I don't want to do number 23. That was too easy because there was only one answer choice with the correct slope. Let's look at number 24. Okay, number 24, it's giving us negative 1/5. There's only one that's got negative 1/5. How about number 25? Negative 8 over 5. Okay, so this is negative 8 over 5 plus 4x. Okay, that's wrong. Negative 8 over 5x. Okay, there's only one there again that's got the correct slope. Let's look at number 26. Parallel to y equals 9/5 x minus 4. All right, so A, the slope is 9/5 x, and in D, the slope is 9/5 x. The only difference is one of them has a y-intercept of 5, and the other one has a y-intercept of negative 5. So actually, these are both lines that are parallel to this one, but we actually have to solve number 26 out in order to find out what the correct equation is. So number 26 is actually the hardest of those four problems. So I'm going to skip number 23. I mean, we already kind of answered it. And we'll write instead down number 26. Okay, we're given 5, 4. And we're asked to find the equation parallel to y equals 9/5 x minus 4. Okay, so this is number 26. This will be more beneficial to you. Okay, so let's get to work here. We're actually ready to just jump right into the point slope formula. Remember, point slope formula is y minus y1 equals m, open parentheses, x minus x1, close parentheses. Our slopes are going to be the same. We know it's going to be, m is going to be equal to 9/5. What we don't know is what the y-intercept will be. So here's how you do this. This is x1 and this is y1. We're just going to plug these values into our formula. Okay, remember we already said m is equal to 9/5. And we got that by looking at our original equation, which was already given to us in slope-intercept form. And bingo, in slope-intercept form, the value sitting in front of the x, that's your slope, 9/5. So m's 9/5. All right, so just plug these values in. Y minus y1, which is 4, y minus 4, equals m, which is 9/5, 9/5, okay, open parentheses, x, and then minus x1, which is 5, x minus 5, okay? So we have, we're going to have to distribute this a little bit. 9/5 times x, okay, and 9/5 times negative 5. We have here y minus 4 equals 9/5 times x, or 9/5 x, and then 9/5 times negative 5. And this one we might want to do off to the side. 9/5 times negative 5/1. Let's make sure we get this right. So multiply the top and multiply the bottom. 9 times negative 5 equals negative 45. And 5 times 1 equals 5. Okay, so I have negative 45/5. And when I divide that out, I actually get a whole number, negative 9. Okay, so what you want to write here is 9/5 x minus 9. Okay, so now I'm focusing in here. I want to get y by itself, so I'll add 4 to both sides. Okay, when I add 4 to both sides, on the left side, these cancel out, leaving y by itself. So now y equals 9/5 x, and then I have negative 9 and positive 4. So negative 9 plus 4 equals negative 5. Okay, so now that's our answer. We go back to our answer choices, and let me share that with you. Number 26, 9/5 x minus 5. Okay, 9/5 x minus 5. So it's D. It's answer choice D. Okay, 9/5 x minus 5. Answer choice D. All right. So that's number 26. This video has gone for an hour, so I'll stop there and try to make a part 2 and 3 later. Maybe it'll take 3 parts. So we've gotten through at least these first few sections here. We've gotten through section 1, section 2, section 3, section 4, and section 5, and section 6. So the next thing will be to find the standard form equation of the line passing through these given points. It's not that hard, and that's where we'll pick up in the next video. Okay, so here's what we did, and we'll end it there.